Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
Hello everyone, I am Dhanusri from class 12. Now in this video we are going to discuss about volume of shapes based on differential calculus related to solid figures. Next we'll see about formulas related to solid figures based on different shapes. Cube. Surface area S is equal to 6x square units. Volume V is equal to x cube cubic units. D diagonal is equal to root 3x units. Here x or A is the side length of the cube. Cuboid. Surface area S is equal to 2 into LB plus BH plus HL square units. Volume V is equal to LBH cubic units. D diagonal is equal to root of L square plus B square plus H square units. Hemisphere. S surface area is equal to 3 pi r square. Volume V is equal to 2 by 3 pi r cube. Sphere. Surface area S is equal to 4 pi r square units. Volume V is equal to 4 by 3 r cube cubic units. Cylinder. Surface area S is equal to 2 pi r into h plus r square units. Volume V is equal to pi r square h cubic units. Cone. Volume V is equal to 1 by 3 pi r square h cubic. Next let's see about some differentiations of each shape related to their formula. First one, cube, volume is equal to a cube. Now we are going to differentiate with respect to t. So dv by dt is equal to 3a square dA by dt. Next is cuboid. Volume is equal to L into B into H. Now I am going to differentiate with respect to t. Then I am going to take this LBH equal to U, V and W, so that dV by dt is equal to LB into DH by dt plus LH into dB by dt plus BH into DL by dt. Next we differentiate with respect to breadth. U is equal to L, V is equal to B, W is equal to H. The same procedure. dV by dB is equal to LB into DH by dB plus LB into 1 plus BH into DL by BB. Differentiate with respect to L. The same procedure. UVW. dV by dL is equal to BH into 1 plus LB into DH by DL plus HL into dB by DL. Next we differentiate with respect to H. Same procedure. UVW. dV by dH is equal to BH DL by DH plus HL dB by DH plus LB into 1. The next shape is cone. Volume of cone is equal to 1 by 3 pi r square h. Differentiating with respect to t, dV by dt is equal to, we are taking two variables u and v. U is equal to r and v is equal to h. So we are proceeding with uv method. Rh is equal to 1 by 3 pi into rh dash plus hr dash. Differentiating with respect to radius, dv by dr is equal to 1 by 3 pi 2r dh by dr. Next we are differentiating it with respect to height. dv by dh is equal to 1 by 3 pi 2r into dr by dh. Next shape is cylinder. Volume is equal to pi r square h. Differentiating with respect to time, dv by dt, the same procedure we are taking uv method. So uv method equal to rh equal to rh dash plus hr dash, the remaining pi. Differentiating with respect to radius r, dv by dr is equal to pi 2r into dh by dr. Differentiating with respect to h, dv by dh is equal to pi into 2r into dr by dh. Next shape is sphere. Volume of a sphere is equal to 4 by 3 pi r cube. Differentiating it with respect to t, dv by dt equal to 4 by 3 pi 3 r square dr by dt. Differentiating with respect to r, dv by dr is equal to 4 by 3 pi 3 r square. Next shape is hemisphere. Volume of hemisphere is equal to 2 by 3 pi r cube. Differentiating with respect to t, dv by dt equal to 2 by 3 pi 3 r square into dr by dt. Differentiating it with respect to radius r is equal to dv by dr equal to 2 by 3 pi 3 r. Next, let's see some model problem mapping MPM. So the first one is a cube. The given problem is dA by dt is equal to 3 centimeter per second and also given A is equal to 10. So that we can find dV by dt with this formula and with the given data. The next is sphere. The given one r is equal to 10 centimeter. To find dV by dr and the formula V is equal to 4 by 3 pi r cube, so that we can find dV by dr with the given values, that is nothing but r is equal to 10. Next is balloon in the shape of a sphere. The diameter given is 3 by 2 2x plus 1, so that we can derive radius equal to 3 by 4 into 2x plus 1 to find dy by dx. So the hint is nothing but dv by dx is equal to d into dx, and just substituting the formula v is equal to 4 by 3 pi r cube. The next is a sphere in the form of air bubble. So the given is dr by dt, that is the radius changes with respect to time is equal to 1 by 2 centimeter per second. To find dv by dt, that is we have to find volume changes with respect to time. So the also given value r is equal to 1 centimeter. So the hint is v is equal to 4 by 3 pi r cube. Next shape is also a sphere which is decreased by the radius. So the given data is r is equal to 10 centimeter. The radius is decreased by 0.1 centimeter. So dr is equal to 9.9 minus 10, that is nothing but minus 0.1. So to find the value is equal to dV is equal to what? That is differentiation of volume is what? The formula V is equal to 4 by 3 pi r cube. The hint dV is equal to 4 by 3 pi 3 r squared. Next, proceeding with some more model problem mapping. The given is cube and the side length is x. The given problem is dV by dt is equal to 50 centimeter cube per second. ds by dt, that is surface area ds, is equal to 10 centimeter square by second. X is the length of the cube. To find x is equal to what and dx by dt is equal to what? Hint is dv by dt divided by ds by dt. Next shape is cuboid. Given h is equal to x, that is height is equal to x, and b breadth is equal to 2x, and length l is equal to 3x. Also given x is equal to 10. To find ds by dx, that is surface area with respect to change x, then dv by dx volume with respect to change of x, and dd by dx is equal to that is dimensional change with respect to x. Hint is x is equal to 10. Just by substituting x is equal to 10, we will get these values. Next, proceeding with cylinder, given h is equal to 5r, that is height is equal to 5r, and also given data dv by dt, that is volume with respect to change of time, equal to 400 pi centimeter square by second, and the differentiation of surface area with respect to time ds by dt is equal to 50 pi centimeter square per second. To find radius is equal to and dr by dt. Hint is substitute r to get dr by dt. That is the given value. We should derive h is equal to 5r and rearrange in the form of r is equal to h by 5. Next, proceeding with cone. The given data is theta is equal to tan inverse of 1 by 2, and also given dv by dt is equal to 5 meter cube per hour, that is volume with respect to change of time, and also given h height is equal to 4 meter. To find dh by dt, hint tan theta is equal to r by h, that is nothing but opposite by adjacent. We just have to derive the tan theta from the cone with respect to their basic formula opposite by adjacent, which is nothing but r by h. Next, proceeding with the applying formula. That is nothing but from a pipe a sand is poured onto the ground, which is in the form of cone. So the given data as dV by dt is equal to 12 centimeter cube per second, and also given h is equal to 4 centimeter, and also given h is equal to 1 by 6 times of radius. So to find dh by dt, hint, h is equal to 1 by 6 times of radius, we are bringing it into r is equal to 6h. Now let's see some example problems based on MPM. Question 1. An edge of a variable cube is increasing at the rate of 3 cm per second. How is the volume of the cube increasing when the edge is 10 cm long? So from the question we are taking given data. The A by dt is equal to 3 cm per second and A edge length is equal to 10 cm. Here I have just shown a cube with the edge length A. To find dV by dt when edge length A is equal to 10 cm. Formula: volume of a cube is equal to A cube. So I have done a reformulation, that is I have done a differentiation. dV by dt is equal to 3a square dA by dt. So with the reformulated formula, I have proceeded the workings. dV by dt is equal to 3a square dA by dt. And substituting 3 in the place of dA by dt, which is also given in the question, 3a square into 3 equal to 9a square. When a is equal to 10, I have just substituted 10 in the place of a, so that 9 into 10 square equal to 900 centimeter cube per second. Hence, the rate of change of volume is 900 centimeter cube. Next question. A balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when the latter is 10 centimeter. So from the given question we are going to take the given values. Balloons remain spherical, okay. Then the radius r is equal to 10 centimeter. So I have drawn a balloon in the form of a sphere with the radius r. To find dV by dr is equal to, and r is equal to 10 cm. That is, we have to find volume with respect to change of radius when r is equal to 10 cm. Okay, then formula: volume of a sphere is equal to 4 by 3 pi r cube. I am just reformulating, that is I am differentiating the volume with respect to radius. dV by dr is equal to 4 by 3 pi 3 r square. And I am just working the problem with the reformulated formulae. dV by dr is equal to 4 by 3 pi 3 r square. Here the 3 gets cancelled and 4 pi r square. When r is equal to 10, that is we know the value of radius, so I am substituting the 10 in the place of r, so that we get 4 pi 10 the whole square. On the further simplification we get 400 pi centimeter cube per centimeter. So dV by dr is equal to 400 pi centimeter cube per centimeter. Hence the volume of rate increasing is 400 pi centimeter cube per centimeter. Next question. A balloon which always remains spherical has a variable diameter 3 by 2 into 2x plus 1. Find the rate of change of its volume with respect to x. So from the question we are taking the given data. Diameter d is equal to 3 by 2 2x plus 1. And when the diameter is given, we can derive the radius. That is, radius is equal to d by 2. So 3 by 4 equal, that is d by 2 is equal to 3 by 4 into 2x plus 1. I have just drawn a balloon with the radius r. To find out rate of change of volume with respect to x, that is dV by dx. That is, we have to find dV by dx. Formula: volume of sphere is equal to 4 by 3 pi r cube. And in reformulation, I have just substituted the value of radius, that is v is equal to 4 by 3 pi 3 by 2 the whole cube into 2x plus 1 the whole cube. So what I have substituted in the reformulation, I have started the working with that. So v is equal to 4 by 3 pi into 3 by 4 the whole cube, 2x plus 1 the whole cube. On further simplification, we get 3 cube 27 and 4 cube 64. And also in the further simplification, we get 9 pi by 16. That is, I have cancelled the 3 and 27 and 4 and 64. So dV by dx is equal to 9 by 16 pi d by dx 2x plus 1 the whole cube. On further simplification, we get 9 by 16 pi 3 into 2x plus 1 the whole square into 2. Here in this 2, I have just differentiated this 2x, which gives me 2. So, the final answer is 27 by 8 pi into 2x plus 1 the whole square, where I have just cancelled this 2 and 16. So, the final answer is 27 by 8 pi 2x plus 1 the whole square. Therefore, the change of volume with respect to x is 27 by 8 pi into 2x plus 1 the whole. Next question. The radius of an air bubble is increasing at the rate of 1 by 2 cm per second. At what rate is the volume of the bubble increasing when the radius is 1 cm? So, from the given question, we are taking increasing at the rate of 1 by 2 centimeters per second. This shows that dr by dt is equal to 1 by 2 centimeter per second. So, generally a air bubble is in the form of sphere. So, I have given a sphere with the radius equal to 1 centimeter. dr by dt is equal to 1 by 2 centimeter per second. To find out rate of volume, that is dv by dt when r is equal to 1 centimeter. Formula: volume of sphere is equal to 4 by 3 pi r cube. I have just reformulated, that is dv by dt is equal to 4 by 3 pi 3r square dr by dt. We have differentiated this in the form of dv by dt, that is per second we have differentiated. So, we get dr by dt in the right side. I have worked this with the same reformulated formula. dv by dt is equal to 4 by 3 pi 3r square dr by dt. We know the value of r, that is 1. So, I have substituted 1 in the place of r, and we know the value of dr by dt, that is 1 by 2, and I have also substituted that. On further simplification, I get 4 by 2 pi into 1, that is I have cancelled the 2 and 4, and the final answer dv by dt is equal to 2 pi centimeter cube per second. The answer, hence, volume increasing at the rate of 2 pi centimeter cube per second. Next question, if the volume of a cube with side length x is v is equal to x cube, find the rate of change of volume with respect to x when x is equal to 5 units. So, from the given question, we came to know that x is equal to 5 units and volume v is equal to x cube. So, I have just shown a cube with the side length a, and what we have to find is dv by dx, that is we have to differentiate volume with respect to x. Formula: volume of a cube is equal to a cube. I have just reformulated in the terms of x, that is dv by dx is equal to 3x square. I have worked this dv by dx is equal to 3x square. We know the value of x, that is x is equal to 5 units. So, I am substituting the 5 in the place of x, so that 3 into 5 the whole square is equal to 3 into 25, and we get 75 units. Therefore, dv by dx is equal to 75 centimeter cubic units. Hence, the rate of change of volume with respect to x is 75 units. Next question, if a radius of the sphere with radius 10 centimeter has to decrease by 0.1 centimeter approximately, how much will its volume decrease? So, from the given question, we came to know radius is equal to 10 centimeter and delta dr, that is the decrease in radius is 0.1 centimeter. That is, if it decreases, we have to take in minus. So, delta dr is equal to minus 0.1. And I have just shown a sphere with radius is equal to 10 centimeter. And what we have to find is dv, that is a differentiation with respect to volume dv. Formula: volume of a sphere is equal to 4 by 3 pi r cube. And I have just differentiated this with respect to radius. dv by dr is equal to 4 by 3 pi 3r square. On further working, dv by dr is equal to 4 by 3 pi 3r square. 3 and 3 gets cancelled, so that we get 4 pi r square into dr. I am bringing the dr this side to the numerator. So, dv is equal to 4 pi r square into dr. We know the value of radius, that is r is equal to 10 centimeter, so that I am substituting 10 in the place of r, and we know the value of dr, that is minus 0.1, so I am also substituting minus 0.1 in the place of dr, so that we get dv is equal to 4 pi into 10 the whole square into minus 0.1. On further simplification, we get 400 pi into 0. That is minus 0.1. So the final answer dV is equal to minus 40 pi centimeter cube. Hence, volume of a sphere decreases about minus 40 pi centimeter cube. We should always remember that if the question is given in decrease by or increase by, if they have given increase by means we have no problem, we can take in positive itself. But if they have mentioned that decreased by this value, then we have to take that value in minus. If we take that in positive, our answer will change. So that we should always be careful in taking the given data. Next question is, if x is the length of the edge of a variable cube, find x and dx by dt when the volume and surface area of the cube are increasing at the ratio of 50 cm cube per second and 10 cm square per second respectively. So from the question we are taking the given data, dv by dt is equal to 50 cm cube per second and ds by dt is equal to 10 cm square per second. I have just shown a cube with the x is nothing but the length of the cube. To find x is equal to and dx by dt equal to, formula volume of a cube v is equal to x cube and surface area of the cube s is equal to 6x square. In reformulation, I have done the differentiation with respect to t, that is dv by dt is equal to 3x square into dx by dt and ds by dt is equal to 12x into dx by dt. I am taking these two as equation 1 and equation 2. We are going to divide this equation 1 and equation 2 as in the question they have given. They are increasing at the ratio of, ratio means we have to divide both. So 1 by 2 dv by d2 by ds by dt equal to 3x square dot dx by dt by 12x into dx by dt. Cancelling dx by dt on numerator and denominator and simplifying 3 and 12, we get x by 4 is equal to 50 by 10. 50 by 10 is given in the question already. So we are equating x by 4 equal to 50 by 10. On further simplification, we get x is equal to 20 centimeter. We have found x. We have to find dx by dt. So for that, I am substituting x in any one of the equation. So I am substituting x in the second equation. ds by dt is equal to 12x. So in the place of x, I am substituting 20. So 12 into 20 into dx by dt. We want dx by dt. So to find dx by dt, I am rearranging those and the final answer is dx by dt is equal to 1 by 24 centimeter per second. Therefore, the length of the variable cube x is equal to 20 centimeter and dx by dt is equal to 1 by 24 centimeter per second. Next question is, if h, b, l of a variable cuboid are x, 2x and 3x respectively, find the rate with which its surface area, volume and diagonals are increasing with respect to x, where x is equal to 10 centimeter. So from the question we are taking the given data, h is nothing but height is equal to x, b breadth is equal to 2x and l length is equal to 3x. Also given x is equal to 10. So I have just shown a cuboid with height, breadth and length. To find this, ds by dx and dv by dx and d by dx, that is nothing but differentiating the surface area with respect to x and differentiating the volume with respect to x and differentiating the diagonal with respect to x. Formula, surface area S is equal to 2 into LB plus BH plus HL and volume V is equal to LBH and diagonal D is equal to root of L square plus B square plus H square. In reformulation, I have done nothing but a differentiation for the volume. dv by dx is equal to 6x cube. On further simplification, we get 18x square. So for working, I am first doing the surface area. S is equal to 2 into LB plus BH plus LH. So I am substituting the values of L, B and H and on the further simplification I got 2 into Lx square and which is equal to 22x square. So I am going to differentiate this. ds by dx is equal to 44x. So I know the value of x equal to 10, which is given in the question. So I am going to substitute 10 in the place of x, so that 44 into 10 is equal to 440 centimeter. Then we are moving on to the volume. V is equal to LBH. Again I am substituting L, B and H, so that I get 6x cube. Now I am going to differentiate. dV by dx is equal to 18x square. Now again we know the value of x is equal to 10. So substituting 10 in the place of x, we get 18 into 10 the whole square equal to 1800 centimeter square. Then moving on to the diagonal, root of L square plus B square plus H square. So substituting the values of LBH, and we get root of 14x square. So x square and the root gets cancelled. We get d is equal to x into root 14, which is nothing but root 14x. So I am going to differentiate this. dd by dx is equal to root 14. So we get ds by dt, ds by dx, dv by dx and dd by dx. Hence, with respect to x, ds by dx is equal to 22x square and dv by dx is equal to 1800 centimeter square and dd by dx is equal to root. Next question is, the height of a closed variable right circular cylinder is always 5 times of its radius. Find the radius and rate of change of radius of the cylinder where volume and total surface area of the cylinder are changing at the rate of 400 pi centimeter cube per second and 50 pi centimeter square per second respectively. So from the question we are taking the given data, h is equal to 5 times of r. So h is equal to 5r. And also given volume is differentiated with respect to time. dV by dt is equal to 400 pi centimeter cube per second and total surface area is differentiated with respect to time. ds by dt is equal to 50 pi centimeter square per second. I have just shown a cylinder with radius r and h height. To find out radius r and dr by dt, that is differentiating the radius with respect to time. So formula V volume is equal to pi r square h and surface area of the cylinder S is equal to 2 pi r into h plus r. In reformulation, I have done the differentiation for the volume. dV by dt is equal to pi into 2rh into dr by dt. So working, I am first proceeding with volume. V is equal to pi r square h. So in place of h, we can substitute phi r, which is already given in the question. So pi r square into phi r. On further simplification, we get 5 pi into r cube. Now differentiating the v, dv by dt equal to 15 pi r square dr by dt. And I am going to substitute the value for dv by dt, that is 400 pi, which is given in the question. 400 pi is equal to 15 pi r square dr by dt. I am taking this as first equation. Then moving on to the surface area of the cylinder. S is equal to 2 pi r into h plus r. 2 pi r, and I am substituting the value of h, so that phi r plus r equal to 2 pi r into 6r. So on further simplification, we get 12 pi r square. Now I am going to differentiate with respect to time. So ds by dt is equal to 24 pi r into dr by dt. Also I am substituting the value of ds by dt, which is given in the question, 50 pi. So 50 pi is equal to 24 pi r dr by dt. I am going to take this as a second equation, and then we are going to divide equation 1 by equation 2. So that 400 pi divided by 50 pi equal to 50 pi r square dr by dt divided by 24 pi r dr by dt. On further simplification, we get 8 is equal to 15 by 24 into r. So we have to find radius. So for to find the radius, I am just rearranging. R is equal to 8 into 24 by 15. On further cancellation, we get R is equal to 64 by 5 centimeter. Hence we found the radius. But the question is not over, because they have also asked dr by dt. That is changing the radius. Changing the radius with differentiation with respect to time. So dr by dt equal to what? Substituting r in any one of the equation, we will get dr by dt. So I am going to substitute r in the second equation, so that 50 pi is equal to 24 pi into r. That is, in place of r, I am going to substitute 64 by 5 and into dr by dt. So we have to find dr by dt. To find dr by dt, I am just rearranging it, and dr by dt is equal to 250 by 1536. On further simplification, we get 125 by 768. So the final answer, radius is equal to 64 by 5 centimeter, and dr by dt, that is differentiating radius with respect to time, equal to 125 by 768 centimeter per second. Next question. Water tank has the shape of an interval circular cone with its axis vertical and vertex is lowermost. Its semi-vertical angle is tan inverse of 0.5. Water is poured into it at a constant rate of 5 meter cube per hour. Find the rate at which level of water rising at the instant when the depth of the water in tank is 4 meter. Okay, from the given question, we can able to take the values. Theta is equal to tan inverse of 0.5. 0.5 is nothing but 1 by 2. So replacing it, tan inverse of 1 by 2. If we know theta value, we can also get the tan theta value. So tan theta is equal to 1 by 2. Also given dV by dt equal to 5 meter cube per hour, and also the height of the tank is 4 meter. H is equal to 4 meter. And I have just shown a cone with radius r and h height, also a tan theta. To find out dH by dt, formula volume of the cone is equal to 1 by 3 pi r square h. In reformulation, I have done the differentiation with respect to t. So dV by dt equal to 1 by 3 pi 2r dr by dt dH by dt. So I have started the working with tan theta is equal to r by h, which is equal to opposite by adjacent. So from the cone, we are taking tan theta is equal to opposite by adjacent. Opposite is r and adjacent is h. So r by h. Tan theta is also equal to 1 by 2. So equating it to r by h is equal to 1 by 2. We get the value of r. R is equal to h by 2. Then we are moving on with volume. V is equal to 1 by 3 pi r square h. In this r, we can substitute h by 2, which we already derived and kept. So 1 by 3 pi h by 2 the whole square into h. On further simplification, we get 1 by 12 pi h cube. Then we are proceeding with the differentiation with respect to time. dV by dt is equal to 1 by 2 pi 3h square dH by dt. We also know h value, h is equal to 4. So replacing h in 4 instead of h, we get 1 by 2 pi into 4 the whole square dH by dt. We also know the value of dV by dt, which is given in the question, 5 meter cube per hour. So I am just substituting phi is equal to 1 by 12 pi 3 into 4 the whole square dH by dt. We need to find dH by dt. So arranging in that order, dH by dt is equal to 5 into 12 by 3 into 16 pi. On further simplification, we get 5 by 4 pi meter per hour. So dH by dt is equal to 5 by 4 pi meter per hour. Therefore, the rate of change of water level is 5 by 4 pi meter per. Next sum, a sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeter? So from the question, we are able to take the given data. dV by dt is equal to 12 centimeter cube per second. That is nothing but the volume is differentiated with respect to t. And also given the height is always 1/6 of the radius. That is nothing but h is equal to 1 by 6 of radius. From here we can find r is equal to 6h. So we able to derive r is equal to 6h, and also the given data h is equal to 4 centimeter. We have just kept those values which is required for the further calculations. And I have just drawn the diagram which shows from a pipe a sand pours which forms a cone on the ground. Then to find out dH by dt, formula V is equal to 1 by 3 pi r square h. That is nothing but the volume of the cone. So I have started the working with the volume of the cone itself. V is equal to 1 by 3 pi r square h. We know the value of r, that is nothing but 6h. So substituting the 6h in the place of r. On further simplification, we get 1 by 3 pi 36 h cube. So v is equal to 12 pi h cube. And then I am differentiating it with respect to time. dv by dt is equal to 12 pi 3h square dh by dt. We also know the value of h, that is nothing but h is equal to 4. So I am substituting the 4 in the place of h. Then the further simplification proceeds. We get dv by dt is equal to 12 pi 3 into 4 the whole square dh by dt. We also know the value of dv by dt, which is given in the question, 12 centimeter cube per second. So I am just substituting 12 in the place of dv by dt. Then we get 12 is equal to 12 pi 3 into 4 square dh by dt. We need to find dh by dt. So I am just rearranging those. dh by dt is equal to 12 by 12 pi into 3 into the 4 square. On further simplification, we get 1 by 3 pi into 16. Then, hence the height of the cone is increasing at the rate of 1 by 48 pi centimeter per second. This is reference. You can refer the sums which we have seen in this video in CBSE NCERT book Max, State Board Max book, and you can also make use of saitechinfo.net, which is available in online to get all the solution for all the subjects exclusively for Max, Chemistry and Physics. You can also refer the answers in CBSE guide, State Board.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.